I'd like to show.
Sorry. Are you playing video?
HDMI. Okay.
Change your screen to duplicate your screen so you can see here as well.
Okay. Okay.
You started on extended link, change to duplicate. I don't use Mac though. Are you alright?
Okay. Hi everyone, my name is Ilayaperumal Gopinathan. I work for Pivotal. I'm from Spring team. I'm a committer in Spring Cloud Stream and Spring Cloud Dataflow ecosystem of projects. Currently co-lead of Spring Cloud Dataflow. I'm here to talk about Spring Cloud Dataflow, and thanks to Mark Heckler on Spring Cloud Stream. So from the previous session, you have got some insights into how an event-driven application can be developed using Spring Cloud Stream framework. There's one other thing that I'd like to talk. Apart from Spring Cloud Stream, we also have a project called Spring Cloud Task. So in any event-driven or a data-driven development, we'll have two kinds of systems. One is a long-running process where we'll have events coming into the system. We'll have event-driven applications. We'll have a long-running application processing the events during, you have a source, processor, sync. And there is also another concept called task application, where your application has a task to complete, meaning it has an exit status. It could either complete successfully or it could come out with failure status. So that's called as a task application. Typically, that can be categorized as a batch-based application. Let's say you wanted to run some transaction processing of like huge volumes of records, thousands of records or millions of records. And that can be considered as a batch or task application. Typically, that's a time-bound application. You don't have that application running for forever, as long as that completes processing and that's done. So that's called Spring Cloud Task. So we also have a Spring Cloud Task framework to write that kind of application. So getting into Spring Cloud Dataflow. Spring Cloud Dataflow is the orchestration toolkit to process your stream and task workloads. And why do we have a unified platform to run both stream and task? There are some unique use cases as well. For instance, you might want to run your task that gets triggered by a stream based on certain criteria. And also in a reverse way, you might want to trigger a stream based on some transaction processing. And as soon as this batch is complete, I'd like to trigger the stream. So that's one of the reasons, but we would like to have the users have a single platform to manage your stream and task workloads. And that's the reason we have Spring Cloud Dataflow acting as a single toolkit to manage both stream, long-running applications, so as task, time-bound applications. In essence, Spring Cloud Dataflow is a RESTful server. It exposes a REST endpoint, like it has a certain REST endpoints for the users to interact with. So using those REST endpoints, you can create and control the lifecycle operations of a stream and task. And you can also create lifecycle operations of the streams as well. It provides the DSL, the domain-specific language, for creating and managing the streams and tasks. It also has a REST client implementations. So we currently have a command line interface, a Spring Shell-based application, the shell interface to interact with. So you can have a script language. You can execute those commands to create, deploy, etc. And also we have a dashboard graphical user interface, and it also comes with the flow editor, which is kind of a drag and drop toolkit. So you can create and manage streams using that, which I'll show in a bit. And we also have the Java DSL. Let's say you wanted to programmatically deploy your streams and batch workloads. You can do that via the Java DSL. Spring Cloud Dataflow is a Spring Boot application itself. It's a server runtime. And if you are used to Spring Boot, and you get all those configuration management and operational efficiencies of running a boot application, so you would deal with Dataflow Server as a Spring Boot app. And it provides the OpenID-based authentication and role-based authorization using OAuth 2. So those are enterprise-class features that you'll get for Spring Cloud Dataflow, which is a key feature for the security. And it acts as a single platform to run against, let's say you wanted to run your workloads on your local. You have created some Docker images. You wanted to test them out. You can run it on your local. And the same thing, you can use the same artifact and push into production. So you can also target to multiple namespaces. Let's say I'm using Kubernetes as my platform. So you can target to deploy your stream workloads and batch workloads into multiple namespaces in Kubernetes, and also multiple spaces accounts in Cloud Foundry. Spring Cloud Dataflow uses a toolkit called Spring Cloud Skipper, which is the package manager. It is Spring Cloud Dataflow delegates the stream deployment request to Spring Cloud Skipper to do the lifecycle operations of streaming applications. Let's say you wanted to do this continuous deployment of applications. You wanted to install your application. You wanted to specifically choose a version of your application. Let's say you have a stream up and running. You wanted to update one of the applications of the stream to a specific version. You wanted to apply some patches when the stream is running. So that is taken care by Skipper. And we also integrate with the Micrometer library. So all these apps can be updated with the Micrometer libraries. So if you want to add Prometheus or InfluxDB, so that can be integrated with your streaming applications as well as task applications. And Spring Cloud Dataflow dashboard also could redirect the metrics monitoring interface into Grafana dashboard so that you can see all those metric monitoring stuff from dashboard UI. We also have this auditing interface, so any operations that gets into Dataflow gets monitored and audited, so which I'll show you as well. Okay, coming to the Spring Cloud Stream based applications, Spring Cloud Dataflow has this concept of app starters. So for all these groundwork, it's already done for over the decade of Spring integration, Spring Cloud Stream, and Spring Batch, everything. So we built on top of that. So what that means is that we are providing some of these out-of-the-box enterprise-class features as applications themselves. So you don't have to write from the scratch. So you can use these out-of-the-box applications, or you can extend based on your needs, or you can customize. And so we provide a list of applications which you can use for your streaming applications. And also for task applications, we provide a framework called Compose Task Runner. What it lets you do is that you can define a flow chart of your batch applications. Typically for a batch applications, you'll have this conditioning logic. So you would derive and execute your batch jobs based on certain steps, right? So let's say a batch job is completed. Now, based on the exit status of this application, I could run the next application. I don't want to run the next steps unless this completes, right? So you can define those logical reasonings inside the flow chart. Basically, you are creating a design, a graph of composed applications together and run them based on the conditions. Okay, so this is the typical flow of a Spring Cloud Dataflow deploying a streaming application. As a user, I'm submitting this DSL. I hope you can see this. So there is the stream DSL. It gets submitted to the Dataflow server. A user submits that using the shell interface or a dashboard UI or a Java DSL. Once it goes to the Dataflow server, it checks against this application registry. This is similar to what you call as a Docker registry, right? So once you build a Docker image, you would like to have your applications registered there. So this could be your Docker registry, right? So for Dataflow server, it requires an app registry where it checks for the registered applications. When it deploys Stream, it checks whether you have registered these applications. These can be Docker images, or if you're using Maven artifacts, you can use the jar files for registering your applications as well. Both Dataflow server and Skipper server has some kind of state management, because if the server crashes and comes back up, it needs some state to recover from the crash, and also it maintains state for like what are all the streams that you have deployed, what are the task-based applications you have deployed. So it's very lightweight schema, and you need a relational database to maintain that state. One other reason that we choose to have a relational database is that people who are comfortable using Spring Batch, so you can also use the same database for maintaining Dataflow server and Skipper server states. Currently, we support the commonly available databases like MySQL, Postgre, Oracle, DB2, and for local purposes, H2 as well. So when the request is sent to Dataflow server, it submits a package manifest request to Skipper server. And like I pointed out earlier, the Skipper server is responsible for the lifecycle management of streaming operations. Like if you wanted to update the stream while it is deployed, then you can do that. You wanted to choose a specific version of a stream, you can choose from the Dataflow server using Skipper. And once the Skipper server receives the request from Dataflow server, it sends this request, the deployment request, to the underlying platform. Earlier I mentioned the single server can be used to deploy multiple platforms, right? So you can choose multiple namespaces in Kubernetes or multiple spaces in Cloud Foundry to deploy your applications into. And so here we support Kubernetes and Cloud Foundry for production-grade workloads. Local is used for mostly on development and debugging purposes. And so this is the workflow. With this, I'd like to switch to a demo where I have my setup running on Minikube. So I have deployed Dataflow server, Skipper server, and MySQL for the database. And I also have Kafka running. So I'm using Kafka as a binder for my streaming applications. So all my streaming applications are bound to Kafka broker here. So I'm using Kafka as the streaming platform here. And with these running, I'm going to go to the Dataflow dashboard. So this is the dashboard graphical user interface that Dataflow server offers. So this is the app registry. So if you wanted to register a new application, you can go here and register your own custom application. And you can also bulk import a list of applications. Like I mentioned, we provide out-of-the-box apps for basic needs or common needs from the enterprise users. I'd like to go over some of the apps that we have. For instance, like it was mentioned in the previous session, so we have source, processor, and sink that kind of connects the streaming pipeline here, right? So you can use these out-of-the-box apps, like if you wanted to read some content from file, a flat file, so or content from FTP server, SFTP, gem file, or you want to connect to a specific table in a database. All these are already available. You don't have to write any code to write an application from the scratch. And of course, you may need to customize something or configure something. Let's say I wanted to connect to a specific table. All you need to do is to provide the table name and the columns that you would like to read from. And all you need is the JDBC configuration. And once it is there, and you can use JDBC as your source. Right? Similarly, we have a mail source. Let's say you wanted to trigger some task based on what you receive as ops email, right? So you can trigger that flow as well. A MongoDB writer, say you are into IoT, so let's say you are doing MQTT as the protocol to receive messages. You can connect to a specific MQTT hosted port or RabbitMQ if you want to receive files from Amazon S3 files or SFTP. So these are commonly available to choose from. And we also have instructions to to the community on how to write an application from scratch. So you would use Spring Cloud Stream as the basis framework to write your application. But I would suggest you to look at these out-of-the-box applications before you start writing anything for your needs. And we also have this Twitter stream, like we have the sample for Twitter sentiment analysis, where all you need to do is to configure the API keys for your application. It will start receiving the tweets from the developer account that you would configure. So these are the out-of-the-box source applications, and we similarly have a list of sync apps. As you can see, there are multiple sync apps similar to source, but it's doing the other thing. Instead of getting the events from the source, it's actually writing back the results. So sync would be your final destination. We also have processors, and this is where it gets interesting. Let's say you're not only writing Java-based applications. You're also into some Python-based applications. You're using some TensorFlow model for your streaming pipeline, using some data machine learning modeling, etc. You can embed that as your processor or computation phase here. So we have these list of out-of-the-box processors available. So we have a TensorFlow model as a processor. We have Python. You can embed your Python script as your processor. It's not only Java or Spring Boot based. So with these kind of configuration, it gives you a powerful toolkit to build a polyglot streaming pipeline, right? And you can also connect to variable clients like TCP client. If you wanted to connect for your processor, you can attach that here. You can also connect to multiple processors. It's not like you need to have a single processor. You can, depending on the condition, you can have more than one processor in your streaming pipeline as well. So with this, I'm going to go ahead and create a stream. Let's say in this case, let's create a HTTP source, which actually a web app and listens for a request from the end user at a specific REST endpoint. And this is out of the box. I am using the out of the box applications here. And let's see, the processor I'm using is transform. So this is again out of the box. It actually requires an expression to be applied on the incoming payload. And I'm using a log application, which is a demo app, which just receives the incoming message and puts it into the application log. Okay, now I'm going to configure these applications. So I'm going to say let's use the root endpoint for this case, and let's say I'm using 9000 as the port, right? And so this is the flow editor I was talking about in data flow. So you can actually configure these applications. And I'm saying expression for the incoming payload, convert the incoming payload to uppercase. And this is just for the demo. So this is where you'll actually insert your business logic or the transformation logic of your processor, right? And I'm embedding my processor. So this is where you can actually embed your Python script or TensorFlow model algorithm or whatever. So you can have multiple processors. And I'm going with the default configuration for log. So it's going to put the incoming message into the log. Okay, so now I'm going to create a stream, and let's call it as a clicks demo. So I'm creating the stream. Now, once I create it, I can start deploying the stream. And like I mentioned, so you can have multiple platforms to choose from when you deploy the stream. So since I'm running this on Minikube, I have only one default namespace unless I have multiple namespaces. So here I have one namespace I chose, and I'm deploying this. I already configured the properties of transform application and the server port to be 9000. So now this is going to get deployed. As we saw before, the deployment request now is going to skip a server, and it's going to deploy into Minikube. And let's get into the Minikube. So I have a watch running. So you see this HTTP transform and log applications with version 1 are running. And I'm going to do port forwarding to post messages on my local laptop so that it gets converted into the port of the Minikube's HTTP application here. So let's do the port forwarding here on this pod, on the port 9000. And this is the shell, the data flow shell. You can do all the things that I did in the dashboard. You can do it from the shell here. So now I'm going to post the messages. This is the utility command that we have. And I'm going to post some message here. And I expect this message to be converted into uppercase by the transform processor. When I post to the HTTP application, which is running on port 9000 in Minikube, since I have the port forwarding mechanism on, this message is going to go and hit the HTTP application that's running inside the Minikube. And the flow of my streaming pipeline is this. I have the HTTP application, which listens at a specific REST endpoint. And as a user, I'm going to hit that endpoint and post some messages. Once the message is inside HTTP, and I have configured this to be running on Kafka, since I have Kafka running, once the message is available in HTTP, it's going to send that message into Kafka topic. And the transform processor would receive the application from a Kafka topic and applies the transformation logic, which in this case, it's a uppercase computation, right? It transforms the incoming word into uppercase and then sends to a different Kafka topic where log application would receive from the Kafka topic. In essence, these applications are distributed and deployed in Kubernetes, and they are connected via Kafka. As pointed out by the previous session, so you can choose RabbitMQ or Azure Event Hub or whatever that's compatible as a binder in your case, or the messaging platform in your choice. Right? So I'm going to start posting the messages. Before that, I'd like to open the log of this log application. Like I said, this log application, simply put, the incoming message in the log. Okay, let's post the message. You see that the HTTP now posted the message and that got converted into uppercase, and you can see that the converted message is now being displayed in the log message. This is just for the demo purpose, but you'll get an idea how a streaming pipeline was constructed using Dataflow and deployed into the target platform. And now I'm managing everything on a single platform, but these applications are running on Kubernetes cluster, right? And one other point is that with this setup, I can also create parallel pipelines. For instance, I can tap into HTTP output and write the incoming data into a JDBC sync. So I can create as many streaming pipelines as possible, right? So that's the advantage of using Spring Cloud Dataflow here. So it gives you that ease of creating streaming pipelines using this model. So I can tap into transform output and redirect that data into some other, let's say, some data modeling or some other data store or some other transformation logic. So we can create multiple streaming pipelines for the same event source. So with this, I'd like to conclude the streaming platform thing, and let's get into the batch side of things. So we'll have 5 more minutes. Okay, so like I said, the task application is a finite duration or a time-bound application. It's not a long-running process. It is expected to complete with the exit status. It should be either completed successfully or completed with a failure. And it is a task is a framework, and a Spring Batch is one of them. Like we can use, if you're using Spring Batch and it is naturally advantageous to you, like if you wanted to move your workload into Spring Cloud Dataflow, you can use this task-based application. You'll get lots of advantages. And also, if you are using Spring Batch and Batch Admin Manager, we suggest the Spring Cloud Dataflow is the next version of Batch Admin Manager. So here, I'm going to create a batch job. So we have a demo application here. So I'm going to construct a graph of application here. So which is a timestamp batch, which has a couple of jobs, which simply puts the current timestamp into the log. And in this case, the timestamp is a timestamp batch is a Spring batch-based application, and I'm going to run them concurrent or sequentially in this case. So you can choose to run your batch applications concurrently as well. You can also apply some conditioning here, like if the batch job completed, then run something. If it fails, then choose to run something else. In this case, I'm running another task. In this case, it's not a batch, but simple task. For example, let's say you wanted to send an email after this batch job is complete. So you can do that as a sequential manner. Once this is completed successfully, then send this email. If it fails, send another email, right? So something like that. So you can choose your conditioning logic. So I have a couple of tasks mentioned here that would run sequentially and simply emits the timestamp here for the demo purpose. So I'm creating this task, and one of them is a batch, the other one is a simple task. A batch is also a task. Task is nothing but a time-bound application. Okay, so I'm now starting the demo. So I actually pass all these configuration parameters. Let's say you wanted to pass some job parameters or application-specific properties. This is the place you would choose to. And I'm launching this task. A task can be launched manually, or it can be scheduled as well. So we also have the provision to specify a scheduler. So we can make use of the platform scheduler by giving a cron expression to say, like, I wanted to launch this job every day, every night, every 1 hour, bi-weekly. So those kind of configuration is available if you wanted to schedule those tasks. In this case, I have launched the job manually. So this is running now. And let's see. As you can see from the log, it has started both the jobs. And this is the batch job, timestamp batch, right? So let's look at the batch jobs here. So there is a specific operations for jobs. I mean, you can see the number of batch jobs. If you're familiar with Spring Batch, you will see what I'm talking about here. With a batch job will have multiple steps. Each step will have a step execution. And you can explore everything from this dashboard. You know, the number of reads, writes, and everything. Because it's mostly related to record-oriented processing, right? Okay, so then, so that's how a batch job can be run. And you can also see both the tasks are complete. So we got the demo first, which is the batch job, and the second is also complete, which is simply putting the timestamp here. So this is the workflow of a task application. So what we are able to do is, when the task is launched, it launched the first job, which is the timestamp batch, and once it completed successfully, then it launched the second task, and then it completed out of it. So you can also define multiple error scenarios in this. So you can directed acyclic graph, so you can configure that here as well. And like I said, you can also monitor the auditing purpose, like all the operations that are going into this data flow server are monitored and updated here. So any operations, since we also have this OAuth2-based authorization for any role mapped here, so all these are logged here. This is more useful for the enterprise users, like what's going on in my streaming platform, who is creating the stream, who is deploying the stream, who is updating the stream, who has rolled back my stream, and what is the status of my batch job, whether it has run successfully or not. So everything you can see and get into the details of it, and including the properties and everything. With this, I would like to conclude, and thank you very much for this session. I hope you find this useful.